Welcome to Math 2318, Section 1.5. In question 1 here, we want to determine if the system has a non-trivial solution. Well, one thing you can notice about this is it does at least have one solution, which is the trivial solution. Because if x1, x2, and x3 are all 0, well, clearly that would solve this particular system. So the question is, does it have a solution that is non-trivial? So if I take my matrix, I do row reduction on it, I see that we do get an infinite number of solutions where x3 is the free variable, and then we get x1 and x2 dependent on x3. So yes, it does have a non-trivial solution. All right. In question 2 here, we're given a system and we want to write it in parametric form. Well, first off, let's just figure out what is the solution. All right, so here's my basic matrix. I took row 1 and divided through by 2. I'm noticing that if I multiply row 1 by 3 and add it to row 2, I get all zeros. And row 3, I'm going to divide by -4. Alright, and so when I clean this up, I'm going to swap out the rows, and I'm also going to make that particular one a 0. So I'm going to take -1 times this row, add it to row 1, and so we have row reduced our particular matrix. Didn't need to do row reduction with a software package because this is fairly straightforward and easy. So what do I see? I see that x3 is free, x2 is 2 times x3, x1 is -4 times x3. And so since x3 is free, I'm just going to call it x3. And so writing this then in parametric or vector form, it's simply x3, my free variable, multiplied by -4, 2, and 1. All right, and in question 3, we'd like to have a vector equation of a line in R3. So let's talk about that for a moment. A vector equation of a line in R3, and this comes up in Calculus 3. Well, it's of the form R of t as my vector R0 plus t. T is my scalar. T is just a real number multiplied by vector v. Well, R0 is a vector that points to the point that I like my line to go through. Alright, so let's say here is the point I want my line to go through. Then R0 simply points to that particular point. Vector v is a direction that my line is going in. So here's vector v. And so R of t simply draws out every point on the line. So it's of the form x0, y0, z0 plus t times my vector for my direction. So let's take what they gave us here. x1, x2, x3 is free. So I'm going to write that in here where the t is where x3 is. Alright, and now if I start separating this, I get 7 minus 2, 0 plus t times 5 minus 7 and 1. So my R0 is 7 minus 2, 0, and the direction that my line is going in is 5 minus 7 and 1. And in the last question 4 here, they are showing me a line M through P and Q. So here's P, here's Q, here's the vectors. So here's the vector pointing at Q. Here is the vector pointing at P. And notice Q minus P is a vector that is parallel to that particular line. So if we want a line going through these 2 points, then it simply is R0 can be either one of these points that I want my line to go through. I just need a direction. Well, the direction is Q minus P. All right, so with all that said, we have here's Q, here's P. Q minus P is pretty easy. 0 minus a minus 6 is 6, minus 4 minus 2. And I get a minus 6. And so that's the piece here for the direction. And it's going through a point, and the point I picked was P. And so that gives us here solution D.